Huge crack opens, ground collapses and explodes. Yellowstone's unstable hydrothermal system reveals its power. Imagine standing in one of the most beautiful places on Earth. Steam rises gently from colorful hot springs. Tourists stroll along wooden boardwalks and the landscape appears peaceful. Then, without warning, the ground shakes. A loud explosion echoes across the basin. Boiling water, steam, mud, and rocks blast hundreds of feet into the air. The Earth literally tears itself apart. This is not a scene from a disaster movie. It is the reality of Yellowstone's powerful hydrothermal system. Recent events at Yellowstone's Biscuit Basin have revealed just how unstable parts of the park can be. Scientists documented a hydrothermal explosion that created new vents, produced a boiling crater, and triggered ground collapse in an area already known for intense geothermal activity. A newly formed crater measuring roughly 21 by 17 feet appeared after the explosion, showing clear evidence that the surface had collapsed into underground voids created by the hydrothermal system. At Yellowstone, enormous amounts of heat rise from magma deep below the surface. This heat continuously warms underground water trapped inside fractures and chambers beneath the park. The result is a vast network of geysers, hot springs, fumaroles, and steam vents unlike anywhere else on Earth. But this beauty hides a dangerous secret. Sometimes pressure builds inside these underground water systems. If that pressure suddenly drops, perhaps because a crack forms underground or the plumbing system shifts, the superheated water instantly flashes into steam. Since steam occupies far more space than liquid water, the pressure can become explosive, violently ripping apart the ground above. That is exactly what happened during Yellowstone's major hydrothermal explosions in recent years. Witnesses described massive columns of water and debris erupting skyward while visitors rushed away from the danger zone. Boardwalks were damaged, rocks were thrown across the landscape, and new fractures appeared in the ground. Scientists later found evidence that the explosion had dramatically altered the underground plumbing system. What makes these events so fascinating is that Yellowstone is constantly changing. New thermal vents continue to appear. Old springs disappear. Underground channels shift direction. Areas that were stable for decades can suddenly become active. Geologists have even discovered entirely new steam vents forming in places where no significant activity existed before, demonstrating how dynamic Yellowstone's hydrothermal network truly is. Despite the dramatic explosions and ground collapses, scientists emphasize an important point. These hydrothermal events are not signs that the Yellowstone supervolcano is about to erupt. Research shows that hydrothermal explosions occur within shallow groundwater systems and are largely independent of the deeper magma reservoir. Yellowstone's magma system remains stable, and current monitoring does not indicate an imminent volcanic eruption. Nevertheless, hydrothermal explosions remain one of the most significant geological hazards inside Yellowstone National Park. Unlike volcanic eruptions, they can occur with little or no warning. The first instrumentally detected hydrothermal explosion in Yellowstone showed that these events may happen suddenly, leaving scientists only moments, or sometimes no time at all, to recognize them before they occur. Today, researchers continue to monitor Yellowstone's restless landscape using seismic instruments, thermal cameras, satellite observations, and gas measurements. Every new crack, every ground collapse, and every explosion provides valuable clues about the hidden world beneath the park. Yellowstone is not simply a national park. It is a living geological laboratory where the Earth's immense energy is constantly reshaping the surface. And every time a crack opens, the ground collapses, or a hydrothermal explosion tears through the landscape. It reminds us that beneath Yellowstone's breathtaking beauty lies one of the most dynamic and powerful hydrothermal systems on the planet. Terrifying. A powerful earthquake shakes Kilauea, a sign of an imminent major eruption? A powerful earthquake suddenly strikes the slopes of Kilauea volcano in Hawaii. The ground trembles violently, buildings sway, and residents across the island feel the force of nature beneath their feet. Within moments, questions begin to spread. Is this the warning sign of a major volcanic eruption? Kilauea is no ordinary volcano. It is one of the most active volcanoes on Earth, constantly monitored by scientists because of its frequent eruptions and complex underground magma system. When earthquakes occur beneath Kilauea, they often indicate that magma is moving through fractures deep underground, increasing pressure within the volcano. Scientists have long recognized that earthquake swarms are among the most important warning signs preceding volcanic activity. Recent observations from the Hawaiian Volcano Observatory show that Kilauea has experienced repeated earthquake swarms beneath its summit region. These earthquakes are linked to changing magmatic pressure beneath Halema Uma'u crater, where magma continues to accumulate and shift underground. Scientists have noted that many of these earthquakes occur at shallow depths, a sign that magma is actively interacting with the volcanic plumbing system. But does a powerful earthquake automatically mean a major eruption is about to happen? Not necessarily. History shows that Kilauea frequently experiences earthquake swarms without immediately erupting. In several past episodes, hundreds of earthquakes occurred as magma moved underground, only for the volcano to remain restless without producing lava at the surface. Scientists emphasize that earthquakes alone are not enough to confirm an imminent eruption. Ground deformation, gas emissions, volcanic tremor, and changes in magma pressure must also be considered. However, when a strong earthquake is accompanied by rapid ground inflation, increased volcanic gas emissions, and escalating seismic activity. The situation becomes much more concerning. Historical eruptions at Kilauea have often been preceded by intense earthquake swarms as magma forced its way toward the surface. During past eruptive crises, thousands of earthquakes were recorded before lava finally broke through the ground. Scientists monitoring Kilauea have recently reported continuing summit inflation, persistent volcanic tremor, and recurring seismic swarms. These observations indicate that magma is still accumulating beneath the volcano. While experts cannot predict the exact moment of an eruption, they acknowledge that Kilauea remains in a state of elevated volcanic unrest and is capable of producing new eruptive episodes with relatively little warning. For now, the powerful earthquake serves as a dramatic reminder that Kilauea is a living volcano. Deep beneath Hawaii's stunning landscapes, enormous forces continue to reshape the Earth. Whether this earthquake is merely another pulse of underground magma movement or the opening act of a larger eruption remains uncertain. But one thing is clear: scientists will be watching every tremor, every crack, and every sign from the volcano in the days ahead. The question remains unanswered, but the earth beneath Kilauea is clearly on the move.